Welcome to the fastest way to learn data structures and algorithms with premium revision material. Today we master LeetCode 72, edit distance. This is the classic two-dimensional dynamic programming problem that powers spell checkers, DNA alignment, and diff tools in every technical interview. Look at the problem statement. You receive two strings, word1 and word2. Return the minimum number of single-character operations to transform word1 into word2. The allowed operations are insert a character, delete a character, or replace a character. Constraints allow strings up to 500 characters, all lowercase letters. Imagine a futuristic autocorrect editor with 3 editing tools on a holographic screen. Insert adds a missing letter, delete removes an extra letter, replace swaps one letter for another. Your job is to morph the source document into the target document using the fewest keystrokes possible. Every DP cell answers one sub-question: what is the cheapest edit cost between the prefixes ending right here? Strategy time. Trick name two-dimensional DP with the 3-way minimum rule. Build a table with rows for word1 plus an empty prefix row, and columns for word2 plus an empty prefix column. Cell DP at row I column j stores the minimum edits to turn word1 prefix of length I into word2 prefix of length j. Base cases: first column equals I because deleting I characters clears the prefix, first row equals j because inserting j characters builds the prefix. When characters match, inherit the diagonal neighbor with 0 extra cost. When they differ, take 1 plus the minimum of delete from above, insert from left, or replace from diagonal. The bottom right cell is the final answer. Enter the spoon-fed detailed dry run. Word1 is horse. Word2 is rose. Display both strings on the left and a live DP scratchpad grid on the right. Initialization. Allocate a 6x4 table of zeros. Fill the first column with 0 through 5 for delete costs. Fill the first row with 0 through 3 for insert costs. At position 1, 1, compare H versus R. They differ. 1 plus the minimum of neighbors 1, 1, and 0 gives 1. At position 2, 2, compare O versus O. They match. Copy the diagonal neighbor 0. DP becomes 0. At position 3, 1, compare R versus R. They match. Copy the diagonal neighbor 1. DP becomes 1. At position 4, 3, compare S versus S. They match. Copy the diagonal neighbor 2. DP becomes 2. At position 5, 3, compare E versus S. They differ. 1 plus the minimum of 2, 4, and 2 gives 3. Scan complete. Bottom right cell equals 3. Return 3. The winning path is replace H with R, delete the extra R, delete E. Pivot to Python implementation. Define min distance on word1 and word2. Read lengths m and n, build a DP table of size m plus 1 by n plus 1. Initialize first column and first row with index values. Nested loops compare characters at I-1 and j-1. On match, copy diagonal. On mismatch, take 1 plus the minimum of 3 neighbors. Return the bottom right cell. Complexity audit restated crisply. Every cell is computed once, giving time O of m times n where m and n are string lengths. The table stores m plus 1 by n plus 1 integers, giving space O of m times n. The 3-way minimum recurrence is the core string alignment pattern interviewers expect. And that is edit distance, mastered for your next on-site. If this helped you today, like the video, subscribe to Leo Academy, and share it with friends who are preparing for coding interviews.